Okay, we're going to go over some of our problems from Friday. So number 1 showed us that we have 4xy minus 19xy plus 5xy minus xy. So our variables are all the same in each monomial. They're an x and a y. And none of them have any exponents, so we can join all of these monomials together. Now, I know a lot of us like to do plus a minus and plus a minus just so we can add the whole way across. So let's start. We've got 4 plus a negative 19 would give you a negative 15, plus 5 would give you a negative 10, plus a negative 1. We can assume that's a 1 in there, which would give us a negative 11. And of course, that's x, y. Now, in our next scenario, we see that we've got AB and AB, but we've got c squared d, c squared d. We've got AB squared. Those can be joined together. So let's do that first, because remember, we're going alphabetical order when we're dealing with variables. So we've got 3AB squared plus 5AB squared. That gives us 8AB squared. And now we can do the c squared d's. It's a negative 2. See that right there? That's a negative 2 or minus 2 c squared d and a plus 6 c squared d for a positive 4 c squared d. Remember, when you're adding and subtracting monomials, their exponents and their variables have to match exactly. They have to be exactly the same. So as we come down to our next one, we see that we've got 6x cubed y plus 6x y cubed. Well, this x is cubed. This one is just assume a 1. You just assume it's a 1. This y is like a 1, but this y is a 3 or cubed. Therefore, there is nothing you can do to this one. You simply have to just leave it because the terms are not identical, so you cannot join them. So your answer just stands as it was. You cannot combine those terms. Now, when you are doing multiplication for monomials, that's a little bit different. So the reason is the bases have to be the same, but the exponents can be different because you are going to be adding the exponents. So let me show you why that works. When you have x cubed, that's like saying x times x times x. And we can see that. 1, 2, 3, or x cubed. X to the 5th is like saying x times x times x times x times x. Or, well, there we go. 1, 2, 3, 4, 5, or x to the 5th. Now, if we come across and count them, we get 1, 2, 3, 4, 5, 6, 7, 8. Well, hopefully that's what we come up with. We have learned that when the bases are the same, and they're both x's, that we simply add the exponents. So we would get x to the 3 plus 5 or x to the 8th. And is that what we counted? 1, 2, 3, 4, 5, 6, 7, 8? Yes. And that's why it works that way. Okay? Now we come on down to number 5. And we've now got coefficients up front here. We've got x's and we've got y. So we're going to do apples for apples. So let's start with our coefficients first. Our 2 and our 3. We just multiply those as we always would. 2 times 3 is 6. Now let's move to our x's. Okay? Remember, when there's nothing there, we assume it's a 1. So x to the 1st power times x to the 4th power is like saying x to the 1 plus 4, or x to the 5th. Now we move on to our y. Y to the 4th times y to the 4th is like saying y to the 4 plus 4 or y to the 8th. and then you're done. Okay? Now, when we add our exponents, multiplying, we would subtract those same exponents when we are dividing monomials. So let's see why that works. Well, we've got x to the 7th, which is like saying x times x times x times x times x times x, 1, 2, 3, 4, 5 times x. That's x to the 7th. All over x to the 4th, which is like saying x times x times x times x. Okay? Now, we know that if there's a number or a variable that's identical in the numerator and denominator, they just can cancel. Why? Because x over x is 1, x over x is 1, x over x is 1, x over x is 1. So those can cancel. And we see that we've got 1, 2, 3 x's left. And if we recall, I told you, we said x to the 7th divided by x to the 4th is like saying x to the 7 minus 4. Remember, when you multiply monomials with the same variable base, you add their exponents, and when you divide, you subtract those. So we would get x to the 7 minus 4, or x to the 3rd, and we come back up here and see there are 1, 2, 3. That is correct. Okay, let's look at this next problem. Again, we're going to take all of our coefficients or all of our numbers and multiply those first. So we've got 1/3 times 3 is 1, times 6 is 6. Okay, now let's move on to our a's. A to the 3rd times a squared is like saying a to the 3 plus 2, or a to the 5th. And then b, there's nothing to multiply b times, so it just stands. And there's nothing to multiply c times, so it just stands as well. There's nothing you can do there. Okay? Now, number 8's a little bit more complicated. We have to multiply these two monomials together, then multiply these two monomials together. Then, if they are exactly the same, you can join them. But we have to multiply each pair together first. Remember, please excuse my dear Aunt Sally. So we always multiply and divide before we add and subtract. So we are going to do our numbers first. 2 times a negative 4 is a negative 8. Let's do our x's next. This is assumed to be a 1. X to the 1st power times x squared is like saying x to the 1 plus 2, which is x to the 3rd power. And there's nothing to match the y up to, so there's just one y. Plus, let's look at our next set. We take our number, 6 times 6, and we get 36. There's 1x. Next squared here. So x to the 1 plus 2 is x cubed. And again, there's just a solitary y. And now we look. We've got x cubed, y to the 1st, y to the 1st. They are identical, so you can join those together. And you get 28 x cubed y. All right, let's look down at our next one. We've got 25 x to the 5th, y to the 10th over 15 x cubed y cubed. Well, 15 doesn't go into 25 evenly, but they both have a common factor of 5. So we know that 5 goes into 25 5 times, and 5 goes into 15 3 times. So we've got 5/3 there, so we're good. Now we have to take care of our x's and our y's. So let's look at our x's first. We have x to the 5 minus 3, or x squared. Why does that work? Let's remember. That's like saying x times x times x times x times x, which is x to the 5th over x times x times x, which is x cubed. Those x's cancel, those cancel, those cancel. That leaves us with an x squared, or x to the 5th minus x to the 3rd. And then we've got y to the 10th minus y to the 3rd, which is y to the 7th. All righty. We had a square in our problem, and well, actually it was a rectangle. And we know that if we're finding the area of a rectangle, area equals length times width. So if this is our length and width, we simply can multiply those. We start with our coefficients, or 4 times 3 is 12. Then we move on to our x's. X again to the first. It's assumed if there's nothing there. So it's like x to the 1 plus 2, or x cubed, plus, not plus, just y. Sorry. Y cubed times y, again, assumed to the first, is like saying y to the 3 plus 1, or y to the 4th. All right. Now our bonus, this was kind of tricky. Again, we have to multiply and divide before we can add and subtract. So this has to wait until we resolve these. All right. So we say 4 divided by 2 is 2. X squared divided by x squared is like saying x to the 2 minus 2. What did we say happens anytime we get x to the 2 minus 2 would be x to the 0? What did we say that became? It always becomes 1. Always, always. And then we've got y squared divided by y to the first. That's assumed. So it's like saying y to the 2 minus 1, or y. Minus, we've got 2 here. Oh, let me put this squared in here because that's how the problem read. We've got x squared minus x squared, or x to the 2 minus 2, which again is x to the 0. Anything to the 0 power is 1. Remember my little song? I know it's crazy, but it's true. Common sense would tell you, look, they would cancel out, which would be 1. Do you see it? See this? They would cancel out. So anything to the 0 power is 1. And then y to the 4th over y to the 3rd is like saying y to the 4 minus 3, which would be y to the 1st. 2 times 1 is 2y minus. 2 times 1 is 2y. 2y minus 2y is a 0, and that was our bonus. Okay, well, I hope you got all of this. If you have any questions, email me. I'll give you a call. Thank you. See you guys later.